In this video, we're going to work through the back page of the phase change calculations worksheet. The first problem, it says, the following problems include both a phase change and a temperature change. You will need to use two or more equations. So in calories, and don't let that mess you up, it just means at the very end we'll change from joules into calories. In calories, calculate the amount of energy that is required to melt 10 grams of ice at 0 degrees Celsius, and then change the temperature of that 10 grams of 0 degrees Celsius water to 50 degrees Celsius. So this walks us through the process, but I want to show you why we are requiring heating curve. Why we are requiring two steps in this process. So here we have a heating curve, our traditional heating curve, and we'll say for H2O, and H2O melts at 0 degrees Celsius and it boils at 100 degrees Celsius. So anytime I'm looking at a problem, I want to find out where I am on this heating curve and where am I going. So calculate the amount of energy, 10 grams of 0 degrees Celsius ice. So we are solid ice and we've got 10 grams. So we're starting here. That's our starting point. And then it says we're going to melt the ice. So we're going to start here, go over to here. But then once that ice is completely melted, we're going to change the temperature from 0 degrees Celsius to 50 degrees Celsius. So now we're going to go from there to there and then up to here. So here, step 1, we have a change in phase, and step 2, we have a change in temperature. There's two different equations for a change in phase and a change in temperature. A change in phase, as we know, the equation is m delta H FUS. And up here, the change in temperature is m delta T CP. So when we look at this, this is why first calculate the energy needed to change the phase. So to change the phase of the ice, it's simply m times delta H FUS. This is the first step. So we take the mass, which is 10 grams, and we multiply it by the heat of fusion. The heat of fusion is 334 joules per gram. The grams cross out. And for step 1, we end up with 3,340 joules for step 1. Next, calculate the energy needed to change for the temperature change. That's the second step. So we've melted the solid ice. Now we're changing its temperature. So we're going to look at this equation. Q of the melted ice is equal to the mass of the melted ice times the change in temperature of the melted ice times the CP value of the melted ice. So that's 10 grams. The change in temperature is 50 degrees Celsius because it states we're going from 0 up to 50. So 50 degrees Celsius. And it is a positive because we're ending up at a higher temperature than what we started. And then 4.18 joules per gram degrees Celsius. The grams cross out, the degrees Celsius cross out. We're left with only joules. So now we get 500 and we multiply by 4.18, and 500 times 4.18 is 2,090. 2,090 joules. So our total amount of energy is Q, the amount of energy to melt the ice, plus the amount of energy to change the temperature of the melted ice. So we end up with 3,340 joules plus 2,090 joules. And when I add those two together, I get a total of 5,430. 5,430 joules to do that process of melting the ice, then changing the temperature of that melted ice. Now, as I just remembered, it did ask for calories. So this final answer I multiply by 1 calorie, a conversion factor, over 4.18. I get that from the front. 1 calorie is 4.18 joules. And so now I take the 5,430, I divide by 4.18, and that gives me 1,299. So technically it asks for calories. So joules and calories are both measurements of energy, but it asked for joules. Asked for calories instead of joules. In calories, calculate the amount of energy that must be taken from. So now we're removing. It's an endothermic. This was an, it's an exothermic. This up here was an endothermic. We were moving this direction, so it was an endothermic process. And now we're going to be going the opposite direction, taking energy out, so it's an exothermic. 100 grams of 125 degrees steam when it's cooled, then condensed to water at 100 degrees Celsius. So now this is the second one. So here's our heating curve. This time they're telling us that we started at 125 degrees Celsius right here at 125 degrees Celsius. Now we go down to here. The steam changes temperature, and then the steam turns all into liquid. So we have step 1 and we have step 2. Step 1 is a change in temperature. Step 2 is a change in phase. So we are starting at 125 degrees Celsius steam. Steam just means a gas or vapor. We change it. We brought it down to 100 degrees Celsius. And then we change it into water, which is a liquid. So not only do we change it to 100 degrees Celsius steam, right here is only a gas, but now we go through step 2 and turn it into a liquid. So we have to remove energy to change the temperature, then we have to remove energy to change the phase. So the step 1 is a change in temperature, and the Q of the, we'll call it S for steam. The Q for the steam is the mass of the steam times the change in temperature of the steam times the CP of the steam. Notice they gave us the CP of the steam right there. If this was just liquid water, it would have been 4.18 joules per gram degree Celsius, but it's steam, and steam is 2.00 CP value. So we're dealing with 100 grams. We're changing by a negative 25 degrees Celsius because we started at 125 and went down to 100. Then we multiply by 2.00 joules per gram degree Celsius. The degrees Celsius and the grams cross out. So now we end up with 50 times 100. So that gives you 500. 25 times 2 is 50. So we end up with 5,000 joules. Now don't forget about that negative. We're having to remove energy. So step 1 requires 5,000 joules. Step 2 is a change in phase. So when we do our change in phase, Q of the steam that's now turning into a liquid equals the mass multiplied by the delta H VAP. So this uses Q equals M delta H VAP. This is Q equals M delta T CP. So this second step, we still have 100 grams of that steam that turned into a liquid, and delta H VAP is a value here that we just look up, 2260 joules per gram. It allows the grams to cross out. We multiply by 100, so I'm going to add 2 zeros to that. So now we end up with 22,000 226,000 joules for that second one. And once again, it's releasing energy, so it would be a negative value. So the Q total equals the first step plus the second step, which would be the 5,000 plus the 226. That would be negative 231,000 joules. They technically asked for calories, so we're going to divide that by 4.18 to cross out the joules. And when you take 231 divided by 4.18, you get 55,263 calories as your final answer. And once again, we're taking energy out, so that would be a negative value. I hope this helps on phase change calculations, where it involves multiple steps: a change in phase and a change in temperature and a change in phase.